Welcome to another Explainer. Now, mark your calendars for July 14th, 2026, because India's Defense Research and Development Organization, or DRDO, quietly completed military field trials of a communication system that fundamentally changes the rules of the game. We are talking about tech that makes eavesdropping on military comms physically detectable. Not mathematically hard to crack, but physically, undeniably detectable the exact second someone tries to listen in. This is a massive leap forward for strategic defense, and today we're going to break down exactly how this quantum shield works.
Okay, let's dive into this. Here is our structured roadmap for today. We're looking at the quantum threat, the physics behind QKD, DRDO's major breakthrough, how to defeat the harvest now, decrypt later strategy, and finally, we'll wrap up with some real-world limits.
All right, kicking things off with Section 1, the quantum threat and the mathematics of vulnerability.
Look, before we can even talk about the defensive shield DRDO just built, we've got to understand the ticking clock of modern encryption. Basically, all our digital security today, military comms, banking, you name it, relies on insanely complex math problems, stuff like factoring gigantic numbers. For a normal, classical computer, that takes practically forever. But enter the quantum computer running Shor's algorithm. It doesn't just guess passwords faster, it literally shortcuts the math, slicing through those barriers like a hot knife through butter. It breaks encryption. Fast. And that is the looming quantum threat we're staring down.
Now, I want to aggressively clear up a massive public misconception here. Do not conflate quantum computing with quantum cryptography. They are completely different sides of the battlefield. The quantum computer, that's the attacker's future weapon, using quantum mechanics to break math. But quantum cryptography, that is our defensive shield today. It uses those exact same physical laws to completely neutralize that future weapon.
Which brings us to Section 2, the physics of QKD shifting from math to physical law.
To defend against this threat, we are shifting our entire paradigm away from complex math over to the immutable laws of physics. So, the crucial point is, what does quantum key distribution, or QKD, actually do? Well, it doesn't encrypt the actual message itself. Actually, let's be more precise. It brilliantly solves a much older problem. How do a naval base and a fleet commander agree on a secret key without anyone snooping? Instead of hoping the math is too hard to crack, QKD uses the physical principles of quantum mechanics to distribute that key with zero chance of an undetected interception. And the engine behind this shield? It's called the no-cloning theorem. This is a foundational rule of quantum mechanics that says, hey, you absolutely cannot create an identical copy of an unknown quantum state without disturbing it. Think of it like this. Your secret key is written on a super delicate pane of glass. With old-school math encryption, a spy can just quietly copy the numbers and work on it in the dark. But with quantum, trying to intercept it is like trying to copy that glass by smashing it with a hammer. It's loud, it's destructive, and we hear it instantly.
Let's walk through how this elegant little trap actually plays out. Step 1. The system entangles photons. Those are light particles, and sends them across the network to carry the key. Step 2. Our eavesdropper tries to sneak a peek or copy them mid-transit. Step 3. Thanks to that no-cloning theorem, just looking at them irreversibly disturbs their quantum state. And finally, Step 4. Boom. Authorized users are instantly alerted. There's literally no way to look at the key without leaving a massive physical fingerprint right on it.
Now, hold on. We need to push back on that unhackable buzzword the media loves to throw around. Let's be incredibly precise here. QTD provides an airtight way to exchange the key. But once that secret key is safely shared, the actual heavy data, the message itself, is still encrypted using fast, standard classical encryption, like the AES protocols banks and governments use today. QKD simply guarantees, by the literal laws of physics, that absolutely nobody swiped the key while it was in transit.
Okay, let's move to Section 3 and see how this builds into India's sovereign tech capability with DRDO's breakthrough.
So let's ground all this abstract physics into the on-the-ground reality of India's indigenous defense program, because this absolutely wasn't built overnight. Back in 2020, DRDO kicked off a crucial partnership with a Bengaluru-based deep tech startup called TechBit Labs. Fast forward to May 2025, they set up a dedicated quantum research center in Delhi, and that culminated in July 2026 with wildly successful military field trials of a fiber-based QKD system. We've officially moved from cool theoretical lab demos to a totally field-deployable reality for the military.
Let's look at the hard facts of what they pulled off. Partnering natively with TechBit Labs means the intellectual property remains 100% sovereign. It's a fiber-based system engineered to survive brutal real-world military conditions. We're talking massive temperature swings and fiber signal degradation. The hardware itself is physically resilient and tamper-evident. Honestly, this is just a massive leap forward for the armed forces and a cornerstone of India's broader national quantum mission.
But you know what the real engineering miracle here is? They made it a multi-hop network. See, a fragile quantum photon degrades pretty quickly over long stretches of fiber optic cable. So a single point-to-point QKD link, that only works over relatively short distances. By engineering a scalable, multi-hop network using trusted relay nodes, DRDO took a short-range scientific marvel and turned it into an operationally viable beast capable of covering the vast geographies a modern military actually requires.
Moving on to Section 4, Defeating Harvest Now, Decrypt Later in the Naval Context. And that raises a huge question. Why does the Navy specifically need this technology?
Well, it all comes down to a really chilling, deeply urgent strategic threat known as Harvest Now, Decrypt Later. An adversary doesn't actually need a working quantum computer today to mess with our communications. Nope. All they do is tap a cable, quietly scoop up all your encrypted military traffic right now, and dump it onto massive server farms. They harvest it today, and then they just patiently wait for quantum computing to mature years down the line so they can finally read it.
And this brilliantly illustrates exactly why maritime forces are uniquely exposed here. Just look at the shelf life of different types of data. If someone steals your regular internet traffic or a text message, by the time they crack it in a decade, it's totally stale and useless. But naval data? We're talking submarine movement patterns, underwater topography maps, long-term nuclear doctrine. That stuff retains its extreme strategic sensitivity for decades. A sub's patrol route today could easily compromise an entire fleet 10 years from now.
This is exactly why QKD isn't just a nice-to-have. It's an immediate necessity. It acts as a permanent, impenetrable shield against that delayed decryption threat. Because the key exchange was protected by the unalterable laws of physics, not just some math problem a future supercomputer could eventually solve, the intercepted data is permanently locked. The adversary could hold onto it for 50 years, and they will still never have the key. Physics guaranteed it wasn't stolen in transit.
All right, Section 5, Real-World Limits and the Future. It's time for an honest reality check.
Look, with any profound technological leap, we need precision over hype. So let's clearly lay out what QKD does not do. First off, you need dedicated fiber optic infrastructure or a perfectly clear line of sight. You can't just effortlessly run this over the messy public internet. Second, like we talked about, the range is strictly limited unless you have incredibly secure relay nodes. And finally, and this is absolutely crucial, QKD only secures the transit of the key. If a spy has already physically hacked the computer terminal inside your naval base, QKD won't magically stop them from just reading the screen.
And those specific limits directly explain why DRDO is running a dual-track approach. While they absolutely nailed the fiber-based trials in July, they're simultaneously pushing the Photonic Technologies for Free Space QKD program. This is an absolute necessity for the Navy. Ships, subs, and mobile assets out in the open ocean obviously can't plug into buried cables. They desperately need photonics shot through free space, usually via satellite, to get those quantum keys securely.
Zooming out, what this all points to is a massive tectonic shift in the broader geopolitical picture. The fact that India developed this incredibly complex, deeply foundational tech indigenously, right under the Atmanirbhar Bharat initiative, is a total game changer. It establishes a genuine 100% sovereign quantum defense capability. India isn't relying on imported black boxes for its most sensitive strategic communications anymore. They are literally building the physical foundation of their own secure future.
Which leaves us with a truly fascinating question to ponder. If math-based security is becoming obsolete, and the immutable laws of physics are now our ultimate defensive shield, what happens to global security when the next battlefield becomes entirely quantum? It's a wild frontier for sure. I hope this explainer gave you a clear picture of exactly how the board is being set. Thanks so much for joining me, and I can't wait to explore more of these incredible breakthroughs with you next time.